Good afternoon, and thank you for joining us for today's web chat. We are pleased to be joined today by Olivier Gupta, the Director General of the French Nuclear Safety Authority. Director General Gupta will be in conversation with the NEA Director General William D. Magwood IV. People from around the world have registered to participate in this event. To ensure a stable connection, and considering the large number of attendees, your video and audio functions have been disabled. There will be a short question and answer session at the end of today's web chat. You have already sent more questions than we have time for, so thank you. But please note that we only have time for a couple of questions at the end, so we may not be able to get to yours. And we will not be able to answer questions in writing. Finally, today's session is being recorded and will be made available online in the near future. It is now my pleasure to give the floor to the Director General of the NEA, Mr. William D. Magwood IV. Sir.
Thank you, and greetings to all of you around the world who are joining us today. It's a pleasure to welcome you to this web chat. This is the next in a series of discussions we have with leaders from around the world talking about important issues and today's challenges. I'm very pleased to welcome today Olivia Gupta. Mr. Gupta is a graduate of École Polytechnique. He's also a graduate of the École Nationale de Pont et Chaussée. He joined the French Nuclear Safety Authority, ASN, in 1999 and held various positions, notably within the Nuclear Power Plants Department. In 2007, he was appointed Deputy Director General with responsibility for nuclear power plant oversight. At the same time, he chaired the Western European Nuclear Regulators Association Working Group on Reactor Harmonization until 2011, when he joined the French National Meteorological Service as a Deputy Director General and was interim chairman and CEO of that organization during 2013. He returned to ASN in 2016 as Director General, and since 2019 has served as chair of the Western European Nuclear Regulators Association, WNRA. Olivia, welcome. It's a pleasure to have you here.
Yeah. Hello, everybody, and good afternoon, Bill. I'm really pleased to be invited in this web chat, and it's a pleasure to see you again after the NEA webinar 3 weeks ago.
Yes, and it's a pleasure to have you here, and this is long overdue. We should have done this a long time ago, even before the pandemic. Well, let's start with something philosophical. You've been Director General since 2016, so you've seen a lot. You've been involved in nuclear safety for many, many years. I often ask people who have spent a lot of time in the nuclear safety field this question. Is there something that you have found, that you have come to understand about nuclear safety that you think that some people haven't quite understood? Is there some insight that you can share?
Well, maybe you will find this very basic, but I would say the main learning would be that nuclear safety requires humbleness. We are working on issues on which we should never rely on certainties. And this has to do with the questioning attitude, which is one of the bases of the safety culture. We have to accept to be challenged. Again, this has to do with openness. And that's also a reason why I like very much having international exchanges. I think they are also a cornerstone of nuclear safety. And coming back to humbleness, this means that even if you belong to a supposed advanced nuclear country, then you are ready to change your practices, your regulations, if you identify a better practice, a better way to regulate in another country.
That's an interesting point. And I wonder if you think that part of your role is to instill that humbleness in the operators as well.
Yeah, for sure. For sure, we need that our licensees, our operators themselves inside their own organizations have this same kind of questioning attitude or openness to what's happening abroad. That's an essential part of nuclear safety. And we have to check that as regulators.
How do regulators influence that kind of behavior?
Yeah, maybe I can, I like the word you use in your questions, the word influencing, because as regulators, we are often seen by the general public as having a role of enforcement towards the licensee. And actually, our first tool towards the licensees is influence. I often like to say that as regulators, we have the licensees we deserve. And for myself, I want licensees that fully ensure their primary responsibility in terms of safety. And that's one of the reasons why we have, at least in France, a regulation which is objective-based rather than means-oriented and prescriptive. This is a way to show them that they should not wait for the regulation to prescribe them what to do. They have themselves to be convinced of what is necessary to ensure a good level of nuclear safety. And another way to say it is that they are not there to please us. That's, I think, a way to influence them. I can give you another example about transparency. I want transparent licenses. And to promote that, I will not base my assessments as a regulator, my assessments about their performances. I will not base it on how many events they report. On the contrary, I will consider that the number of events on each plant is more a measure of the transparency of the plant than of the safety level of the plant. These are two examples.
No, I think that's it's a simple statement, but it's actually quite profound to say that we want to see operators not just simply please the regulator, but do the right thing. But everything that regulators do has an impact on how the operators behave in some sense. And I like your phrase that you have the operators that you're the licensees that you deserve. I think it works both ways. You know, the licensees get the regulator they deserve, right? Yeah. And so I think if the regulator, because it becomes an issue of trust between the two, and I certainly find that that's different around the world. And I think in your role as the chair of WNRA, you probably see these differences as well.
Yeah, I would say that in Europe, we have a quite homogeneous situation, but you're right that the situation varies depending on the country, depending on the histories. Also, for how long have you been engaging with such regulator? So yeah, that's true that it can vary over time and also depending on the countries.
So as you interact with countries, particularly countries outside of Europe, do you see areas where there are major alignments and major differences between how ASN proceeds with different issues, safety issues, and the way that other regulators deal with them? What are some of the examples of alignment where things are very clear and differences that you see that raise interesting issues?
I would say that on the whole, there is a very wide convergence on most issues, and I could say on the major issues. And I think this is the result of the various existing international frameworks and the long-term and the long-lasting relationships that all nuclear countries had within these frameworks. And for instance, if I take the 10 safety fundamental principles from the IAEA, I think they are largely shared by all nuclear countries. I could take also another example, the lessons learned from the accident of Fukushima. They are also largely shared because also they have been built jointly, these lessons, as was very well shown by the report that your agency released 3 weeks ago. So wide convergence on the whole. However, you're right, there are still some differences. One of them is about the safety objectives for long-term operation, especially, I would say, between the United States and Europe. There is this discussion whether we should maintain safety versus improve safety for plants which are requiring operation beyond 40 years or even more. There I see a difference. Maybe another example is in the way the PSA results are used in some countries. Regulators tend to ask more evidence than just the result of the PSA. They are asking also evidence coming from the deterministic demonstration, whereas maybe in some other countries, the result of the PSA can be used in a more self-standing manner. Maybe a last example of difference I can quote is about the use of the INES scale. We have this INES scale, which is internationally shared, but I think that it's not used exactly in the same way in the various countries. You just see it if you look at the number of events which are declared in large countries. It should roughly be the same. It should roughly be proportional to the number of power plants. There is no reason why there should be more incidents in such or such country. And if you look at the figures, it's not the case. And I think it's because we are using it in different ways. It's not such a big issue, but it's an example of difference.
Yeah, I mean, I think that one of the more visible differences is the issue you mentioned about long-term operation. Colleagues in the US are having these early conversations about plants operating for 100 years, which would be very difficult to imagine taking place in most European countries. Does that present any challenges from a public communication standpoint? Do people ask ASN, well, why is it easy to do this in the US and why is it hard to do it in France, or maybe in the case of the US, or there are probably people asking, well, why is it safe to operate 100 years in the United States and only 40 years in France? How do you see that from a public confidence standpoint when you see those stark differences between major regulators?
Well, I don't see so many, at least in France. I will not speak about what's happening in the US, but at least in France, I don't see so many questions from the public. We have sometimes some questions by the licensees, which take the example of what's happening in the US to say, well, we could do the same, but not really from the public itself. Okay.
So sort of coming back to the European situation as your role with WINRA, harmonization of safety in Europe has been, there's been a real effort to converge towards very, very common standards and common approaches. And it's remarkable how much work has gone into that, particularly since the Fukushima Daiichi acts. I think it's really doubled the efforts. What role does safety reference levels play in that work?
yeah, maybe just to start with the safety, because I'm not sure everyone knows what we are talking about. The safety reference levels are the tool which has been developed by WENRA, the club of the European regulators, to as a basis for harmonization in Europe. This is really the main instrument. These safety reference levels, they are based on the IAEA safety standards, so they don't come from nowhere. They are based on the IAEA standards, and we have selected from the standards the items that were the most relevant for harmonization in Europe. I mean that we picked up the items where we thought we may not be fully harmonized, and that's the way we built the safety reference levels. And we also added to the IAEA standards, we added, I would say, some of the European best practices. And on the basis of these safety reference levels, we have harmonized our national regulations on a voluntary basis that was not mandatory. And I think it's very important that it was not mandatory, because this is the reason why we all agreed to start the exercise, because it was not mandatory. However, the heads of nuclear regulators in Europe voluntarily committed to implement these safety reference levels in their national regulations to achieve this objective of harmonization. And that was the process. And this implementation of the reference levels in the national regulation was peer-reviewed, was benchmarked among ourselves, so that we could prove and show to the general public or to the stakeholders that harmonization was not just a word, but that it was really achieved. And I think we can be quite proud about the result, because we are there now. We have harmonized regulations all over Europe, thanks to this instrument. I think it's quite an achievement. I was there at the beginning of the year 2000, when we started this exercise inside WENRA. I don't know how many of us would have bet that we would succeed, because it was quite crazy to engage in such a difficult task. But really, I'm quite proud 20 years after to see where we are now.
Yeah, no, it's quite an accomplishment. Well, let me interject a question from the audience that's already come up. And I found this one interesting. This is from Nuclear Transparency Watch, which I'm sure you're quite familiar with. And they note that that they are one of the groups that are concerned about the independence of regulators and whether they use the most robust approaches and safety rules to assure safety. And they asked this really interesting question: would you support the development of an international mechanism to monitor the independence of nuclear regulators?
Well, it would depend on the mechanism. I think we already have international mechanisms through which we report about our own statuses. We have the conventions under the IAEA, and when as ASNDG I report about the situation of nuclear safety in France, I start by making a point on how ASN we are regulating, what is our status, how independent we are, and all other colleagues do that kind of report. So I think it's a way to have some kind of collective pressure, so that we have independent regulators in all countries. We have also the same kind of reporting mechanisms at the European level. We have directives. But we have to recognize that independency of the regulators did not, even in what we could call advanced nuclear countries, it did not happen from one day to the other. It took much time. If I take the French example, it was a very long way to become fully independent. The French Nuclear Safety Authority had various statuses. Our status evolved over time. We first have been independent from the licenses, for sure, but then, and that was more recent, that was in 2006, which is not so long ago, independent also from the government. And if you look in other countries, some regulators are at this final stage of independence, but some other are a bit beyond. And I think we cannot blame them, because that was exactly what happened in our own countries. This is the history of nuclear safety also.
Yeah, no, I agree with that. I think that there certainly has been a trend towards greater independence, which I think has been quite successful. And we interact with some countries that are now making that transition, and it's not an easy one, because there's a lot of history, a lot of infrastructure, lots of questions about how to divide up the staff and the resources and the laboratories. So when they have to make those changes, it can be quite complicated. So I do appreciate, though, that I think that the message has been very clear that the independence is extremely important. And if anything, the accident, Fukushima Daiichi, really reinforced that message around the world. And I think people heard it very clearly. I wonder, is it because you have the unique, I've worked in nuclear basically my entire professional career, but you've dipped out a bit here and there. We're doing some other things. Did you gain any insights from these other sectors that you think are relevant to issues in the nuclear sector that you bring over from other industry areas?
Maybe you refer to the fact that I have been working for 5 years for the French Weather and Climate Service, Météo France. Yeah, it's an issue. It's a field which is technically very different, obviously. But I could say it's also about risk management, natural risks, floodings, and so on. And it's also about very long-term issues, such as climate change. So these are at least two common points with the nuclear sector, in which we are also dealing with very long-term issues. Just to give you an example, we had the same kind of issues about the need to reinforce the culture of risk in the general public, especially to avoid inappropriate behaviors during severe floodings. In France, we have experienced, and this is the case also in other countries, severe floodings, which come very quickly, and and we see as an experience feedback that we need to better educate the general public about what should be done, and especially what should not be done in such situations. Another common point I see is about international relations. Weather and climate, this is also, such as nuclear safety, a field in which we absolutely need to have international relations. You cannot forecast the weather for tomorrow or 3 days after without knowing what's happening all over the world now. So you need to have international relations. And exactly as in the nuclear sector, there were institutions, international institutions, but also informal clubs. And at the European level, it was interesting to see that there was also the same need to have the kind of club that we had with WENRA for nuclear safety. So this is interesting. And I could say that beyond my personal experience, in ASN, we are trying to have people that have been working also in other fields than nuclear safety and radiation protection. And that's not only a matter of technical competencies, that's also first and foremost an issue of mind openness.
You know, you mentioned and I found it interesting. You were talking about how in the area of when you're looking at flooding and other natural events, you think about risk. And of course, you know, as you know, calculating those risks can be very difficult when you're looking at floods and hurricanes and those sorts of things. But still, when you're, especially when you're talking to the public, how do you translate these issues of risk, whether you're looking at it from the perspective of natural disasters or a nuclear power plant operation? How do you see the best way to communicate the concept of risk to the general public when you're trying to explain the basis for regulatory decisions?
Well, it's not an easy question. I think that we need to start making complicated issues simple, because we are dealing with difficult issues. Nuclear safety is very complex. And the first thing is to be able to explain it in simple words that are understandable by the stakeholders. It's even more difficult. When I talk about the stakeholders, I think about especially the non-governmental organizations, because they are used to talk to us, so it's a bit easier. When it comes to the general public, really it becomes difficult because they are not used to interact with us, and it's more difficult to convey the messages. We are also trying to use local structures to get in touch with the general public. I think that the general public is the better hear the messages when these messages are conveyed by people who are living in the same community. It can be the mayor, it can be local representatives, it can be also people from local NGOs. But I think these people can also help us to convey these messages in terms of risk culture.
Yeah, I agree. I think this is a very difficult concept to discuss with people that don't live in that world. You know, we as a matter of fact at the NEA, we have a group of people currently that I think some of your staff are involved in, looking at developing a risk communication school, you know, to help regulatory staffs talk to people about these subjects in some fashion. And one of our committees a while back was considering developing some kind of scale to communicate radiological risk, some almost like the Richter scale, something very simple and very easy to communicate. But there's no magic solution. It's a very difficult subject. Now, I'm sorry, please.
Yeah, maybe if I can just add a word about that. I think it is very important also to, when it is possible, to make the local people acting in their own protection. And when talking about that, I am thinking about what has been done in Japan around Fukushima, giving people devices to monitor radiations so that they can themselves be their own radiation protection advisor, their own advisor. If I don't know if it is understandable, but you see, when they act themselves, I think it's the best way for them to understand and to implement the protective measures.
Yeah, I agree with that. I think the observation I would make is that the people, and I admire what the people in Fukushima Prefecture have done. They've become very sophisticated in thinking about radiological risk and thinking about contamination issues. And I notice when I meet with them that they're not afraid of it. They understand it, they manage it, and they're not afraid of it. And I think that's really quite instructive, because I think part of the challenge that regulators have is that the public that they serve doesn't have the time or the interest to understand these radiological issues the way the people of Fukushima Prefecture have had to understand it. And therefore, you don't have the base of knowledge to discuss these issues. So they do become better managers of their own situations. So it's I think it's always the adage that the people don't learn about these things until after something happens, and by then, of course, it's a whole different situation. Risk though is something that people in the regulatory business and in the operations business manage. And you mentioned the use of PSA as one of the tools that you use. And we had a question from the IAEA about this, and wondering how do you manage the integration of deterministic tools and probabilistic tools when making safety decisions? How does ASN manage that?
We use both, and they should never be opposed. These are two valuable insights that we need to use, that we need to look at before making a decision. A good decision, to make a good decision, you have to use, not necessarily to use, but at least to consider. You have to consider all available information. So for sure, we are using the results of PSA, but what I wanted to say earlier is that at least in France, we have a tendency also not to rely solely on quantitative results, on these figures that come from PSA. Each time it's possible, we balance it with engineering judgment. We balance it with the results of deterministic studies, and we have a collective discussion inside ASN. I would say from the engineer which has been assessing the file to the commission and the chairman, a very collective discussion. At the end, the commission decides, the 5 commissioners decide. But I think this collective way of discussing and trying to weight the pros and cons, the various arguments, I find it a sound way to proceed. In some cases, it takes a bit time. We need several meetings with the Commission to make a decision, but I think it has proven to again to be sound.
I wonder, it would be interesting to watch some of those discussions, because I wonder if you have sort of the deterministic faction and the PSA faction arguing. Does it work that way?
No, not at all. Not at all. Really, these are insights that we are taking. We are using also the experience feedback, comparisons with what we have decided on similar cases, what could have been decided also in other countries. But I would say many considerations are coming in line. And I have never had the impression that PSA results could have been strictly speaking opposed to deterministic arguments. I think it's really from the basis, I would say all of them are integrated. Well, we should invite you to observe.
I would like to see that. Yeah, it would test my French. Well, where this becomes particularly interesting, I think, is when you think about the new technologies that are coming up. There's a lot of conversation about small modular reactors, Gen 4 reactors with very different safety characteristics. And I wonder, how do you think about this? I know ASN has done a lot of work in the past on sodium fast reactors, the NEA project with new technologies. But now you have another new class, these reactors with very large water inventories, different fuel configurations. Does ASN's regulatory framework, is it flexible enough to deal with these new technologies?
It's true that there is currently a great interest worldwide about small modular reactors. You mentioned Generation 4. I was starting my career at ASN at that time, but I remember also the enthusiasm that was there about Gen 4 in the nuclear sector. That we must recognize that there have not been many concrete constructions since then. But however, you're right. As regulators, we need to engage early in this kind of discussions, in this kind of new projects, because otherwise, if we come too late in the discussion, we miss really the occasion, the opportunity to influence, to take this word influence again, to influence the choices of the industry, and also to set ambitious safety objectives. So yeah, we need to engage with the industry early. Regarding the small modular reactors, I was just mentioning ambitious safety objective. I think the question is, can we get with small modular reactors a better level of protection for the people and the environment than what we have with Gen 3 plants? At least we expect at least the same level as Gen 3 plants, but can we have better? I don't know. Frankly, I don't know. This is an open question. It has to be discussed with the industry, and it has to be discussed again at a very early stage. So we are not the most advanced country in this discussion in France, because there are more advanced projects in the US, for instance. But we domestically, we have one project which is from the French industry, which is called New World, with several partners. It is at the stage of preliminary design studies, and we are engaging with the industry. We are starting the discussion with them. ASN has also been involved in several international forums, and this is very useful for us to gain experience and insights from foreign counterparts. And you are in the NEA hosting such a forum of discussion, which is very useful. We also discuss within the IAEA. We have also discussions within WENRA. And we have also bilateral contacts with Canada, US, and UK, where there are also SMR projects. And you asked me about the regulatory framework. We have the chance in France to have an objective-based regulation, which is not very prescriptive. So actually, I don't see any obstacle in the French regulation to the development of new technologies such as SMRs. Our system does not so much rely on regulatory prescriptions. It really relies on an in-depth technical dialogue with the industry. So this leaves plenty of possibilities for new technologies and innovations.
It tempts me. Well, we should probably have this conversation offline one day, but it does. I do wonder when I think about these new technologies. You know, some of the technologies that are being taken to regulators and around the world. Some of them claim to not require any offsite emergency preparedness. Is that conceptually something that the framework that ASN uses could absorb? Is that a possibility in the ASN framework, assuming the technology could be proven to work that effectively?
Strictly speaking, it could. We could imagine that, but I am always reluctant to be in a situation not to envisage anything as in terms of measures to manage an accident. I think that the way safety relies on defense in depth, and accident management is one of the major lines of defense. So really, I would be very reluctant to abandon this line of defense, even if the industry could prove me that there will never be any consequence of sight. It's the question. I am coming back to humbleness and this question of about certainties. I think we should always envisage, or at least we should never discard the possibility of an accident. So I would not be comfortable with putting that or letting that away. This does not mean that I would not welcome a design that would claim that there is no need for such protective measures. But that would be a good design. But even if there is no need for such measures, I think it's good to have provisions for them anyway.
Yeah. Defense in depth approach. Yeah. One more technology question. You know, we've started having a series of webinars in cooperation with Kerry of Korea looking at disruptive technologies, artificial intelligence, advanced manufacturing, big data. I think this is an area where France is actually quite advanced. I had the opportunity to talk with experts in EDF not long ago, and they seem to be taking a lot of looking at these technologies as something that could come into the nuclear sector, really not in the distant future. What challenges does that present to ASN?
It's always a challenge for a regulator to review and to license what you call a disruptive technology, because as regulators, we are more comfortable when the licensee brings to us a design where which has already some large experience feedback. You see, so but we have proven at ASN that we are able to do that. I remember in the 90s when we had to license the instrumentation and control system of the N4 plant, which was fully digital, which is fully digital. That was fully new at that time, and we did it. We are also at the moment licensing ITER, which is a fully new and unique facility. And as I just mentioned, we rely on this in-depth technical dialogue. We are asking, so we in some cases, we cannot ask for proven technologies. So we are asking for how they qualify these new aspects. Another example I can give is about the core catcher of the EPR. There had been a research program with some tests with non-radioactive material to simulate the corium to see how it could spread and so on. So it can take longer, but we have to be open to that. I don't think it would be good to be in a situation that innovations cannot be proposed by the licensees anymore.
You know, as you talk about these new technologies, including things like digital instrumentation, that requires a different skill set for some of these technologies. Artificial intelligence, analyzing artificial intelligence or analyzing advanced manufacturing. Those aren't the typical range of technologies that nuclear regulators usually deal with. So this requires new people, new skill sets. Or has ASN been building its staff to meet these new challenges? How do you deal with these new skill requirements?
I must say that for the moment we are not so much advanced in the topic. We are starting discussions with industry about what they are doing with artificial intelligence. We also have our own IA projects as a regulator, IA tools to better orientate our inspection programs, to make a better use of all the data we have collected during our previous inspections. Still, we are a regulator. We are not belonging to the most advanced companies in terms of such items. That's a reality. We have some skilled people in the domain, but not so many.
Yeah, it's a challenge. I remember when cybersecurity became a major issue for nuclear regulators. That was a bit of a shock. and many of them had to work very quickly to try to build expertise in those areas. And I think it's still difficult for a lot of regulators because it's not where nuclear safety has been technologically, but now it's an important area of consideration. Let me give you a question from the audience, and we'll start. I think we have to start wrapping up soon. But one member of the audience notes that a large number of nuclear power plants are going to be reaching the end of their operational lives, particularly in Europe. Do you feel that there is a good consensus, and let's stay with the European case for now, but is there a good consensus in Europe for how regulators are going to deal with decontamination, dismantling of these plants?
It is an issue which is addressed in one of the WNWA working groups, dismantling, waste management, and so on. So we are trying to address it. I must say that we don't have exactly up to now the same practices in terms of, first of all, in terms of dismantling, on whether dismantling should be immediate or whether it can be deferred, and also about release threshold for very low waste, very low radioactive waste. In some European countries, you can release waste, radioactive waste as general waste, provided that you can prove that they are contaminated below a certain threshold. For instance, this is not the case, at least for the moment, in France. So, yeah, you're right. This is an issue where we still don't have exactly the same policies. And I must say that it's not only in the hands of the regulators, it's also in the hands of the governments, because some of these aspects are fixed in the laws, and this is not in our hands.
Good. Understood. One more audience question, then I'll ask you sort of a wrap up. And this is an interesting question that comes from Platts, and they note that ASN recently approved EDF's request to use robots to repair 8 defective welds at Flamanville 3. Can you tell us a bit about that work, and when will it start? And maybe you can make a comment as to why robots were necessary as opposed to some more conventional approaches.
Yeah, it took several months to get to this conclusion. You remember when this issue of the welding, the way some pipes of the Flamanville EPR were welded was not correct. At least it did not meet all the requirements that were applicable. So we had to make a very tough decision. We were aware at that time that by making this decision, the commissioning of EPR would be delayed from 2 to 3 years. We made this decision anyway, because technically this was the right decision to make. And I think that we were able to make it also because of our status as an independent agency. Again, relying about taking into account the technical data that we had in our hands. And then, yeah, this is an example of a new technology that was developed by EDF with robots to weld to do the welds by the inside. This was already used in the US, so they had some experience feedback to show us, but it took us several months to discuss with them and to review their file, and finally to give them this green light. And this is an example of the way we work with the licensee.
And when will that get started? Do you know? The robot welding.
When will it get started? Well, I don't have the the date in mind. I think it will start quite soon now. They needed our approval, but I think now it will. They will do it quite soon.
Well, thank you. Well, one last question. We'll end with this, and we make the observation. This is the March on Gender. Everyone's been talking about this, and this is something that the NEA, the OECD have been talking about quite often for the last couple of years, and there are different efforts to try to get more women into nuclear science and technology. What's your thoughts about this? Is this something that's really important? And if it's important, what should we be doing that we're not doing now?
Yeah, sure, for sure. But I would say that it's much more general than nuclear science and technology. I would say it's science and technology as a whole. I think there have been improvements, at least in France, over the 10 or 20 past years in the educational system. The share of women in science and technology has increased. I think maybe it's roughly around 30% now. So it's better than it was before, but you see it's still far below 50%. Mm. And it's the same in the specific case of nuclear. What I can say is that what we do at ASN is that we pay attention to, I would say, the well-being at work, and pay attention to give our staff, to offer our staff working conditions that allow both, I would say, both men and women to have a balance between their professional and private life. And I say both men and women because I think men are also keen to have a balance between their private and professional life. And I think also it's a way to show that, well, our positions are open to anyone. And just to give figures, we have 45% of women in our staff, in the whole staff of ASN, and almost 40% being in senior positions. Mm. So we are trying to improve, but it's already, I think, not so bad.
Yeah, no, I think ASN might be ahead of a lot of organizations. That some of the numbers that I've seen suggest that the number of women in, say, technical and technical leadership positions is in the teens. 12%, 15%, somewhere in there somewhere. At NEA, we're better than that. We're about 30%, 32%. So we have some growth to do there ourselves, but I think we're moving in the right direction. But anyway, it's been a real pleasure talking with you. Thank you for joining us. This has been very interesting. I look forward to welcoming you back for other discussions on other issues. And but again, thank you for joining us today.
Yeah, thank you very much, Bill. It was my pleasure. And as usual, these events are very well organized by the NEA in a very professional manner. Thank you for that.
Merci beaucoup. I appreciate that. Well, with that, we will conclude, and I will hand it off to the disembodied voice to close us out.
Thank you very much to you both, and thank you very much to all who listened in. We appreciate your participation. The webinar has been recorded and will be available on the NEA website soon. You can also follow the NEA on Twitter and LinkedIn to keep in touch with us and receive updates on our programs and events like this one. Thank you, and good afternoon.